In this video, we discuss how to plot signals with scaling in time and shifting in time. For example, here I want to plot pi of 5t plus 3. So 5t, that's a scaled in time, and plus 3, that's shifted in time, shifting in time. Okay. Before we do that, let's talk about pi of t. So this is the signal we defined in the basic signal. We know pi of t is rectangular. When t is in minus half to half, the value is 1. And beyond that range, everything is 0. Here is all 0. Now, notice that this is the function argument. Anything inside this bracket, that's the function argument. It can be represented by any symbols. For example, this function, I can express that with pi of x. Now, x is the argument. If we plot this function, the argument is x, the variable is x. So x is in the x-axis. It has values changing from minus infinity to infinity in the real line. The same thing pi of t. So t here is the variable, is the argument that is running from minus infinity to infinity here. These two functions, if we look at the shape, the function shape, the graph, that's exactly the same. So here that's minus half, this is half, and this is magnitude 1. This is exactly the same. So now, if we want to plot this, and the whole thing in the bracket here is the argument. So when this argument equals to minus a half, so there's a change in the value of the function, that's from 0 to 1 here. In this argument, anything inside the bracket when is equals to half, we know this is a critical turning point where the function will change. This t and this t, although the same symbol, but they are different. This is the argument. The whole thing here is as a function, as a row. The whole thing in this bracket has the row of t here in this function, or the whole thing in this bracket has the same row as x for this function. So we know that as soon as we know pi, if we know this function is pi, we know that is the rectangular. We know that's rectangular, but we need to know, I know the magnitude is 1, we need to know the value of t. This is a value of t. What is the value of t that is going to make change from 0 to 1 for the function value? We know that when this argument equals to minus half, the function values is going to make such move. So therefore, we need to find the value of t. We need to solve a linear equation. I'm going to use different color. So it should be 5t plus 3 equals to minus half. So that's, if I solve the equation here, that should be the value of t, where the function values is going to change from 0 to 1. So if we do 5t equals to minus 7 divided by 2, so t equals 2. Divided by 5, that will be 10.7. Okay, sorry, that will be minus 7 divided by 10. And this, the value of the t here, we do the same token. When this whole thing equals to half, the function value is going to change. We need to solve this equation here. The value become half. That is equals to half minus 3, that equals minus 5 divided by 2. Therefore, t equals to minus half. Okay, so here that's minus half. And here that's 0. That's the middle point we need to find out here. The middle point here will be 0. The middle point corresponding to the argument equals 0. So argument is 5t plus 3. That should equals to 0. So we solve this linear equation. That will be minus 3. So t will be 5. 3 divided by 5 minus. So this will be minus 3 divided by 5. And then if we plot, if we know that this should be the y-axis, that should be the y-axis, the magnitude will be 1. We know this is our y-axis, and the value is here is 1. And here this is the y-axis, the value is 1. So now this figure is complete. Now in the prereq, I'm not sure how this situation was handled the way you were taught. I know some of just remember which way to shift depending on this number, positive or negative. Students remember is going to shift to the right, shift to the right or shift to the left, whatever. In regarding the scaling, the students memorize, oh, the figure is going to shrink or going to expand. That if we can memorize the rules very, very precisely and correctly, it's okay. You can use it. But this is the way I prefer this way. This is a strategy for any figures, any graph, any scaling, any shifting. This is the way how we plot it. So we look for the critical points here, and then we found the value of the variable of t here. No matter how it shifted, how it scaled, we need to solve the linear equations on these critical points, and then we can figure out the correct graph. For me, I do not memorize anything, but this is a strategy to obtain the correct graph.